Basically, what we're gonna deal in this session is basically the thermodynamic properties. There are two basic coming on to the thermodynamic properties. We should know what are the approaches in thermodynamics. One is the macroscopic approach, another is the microscopic approach. The things we're gonna discuss is macroscopic approach. The microscopic approach deals with the effect of molecular motion, and that is quite difficult to analyze. Okay. So now we're gonna deal is basically the macroscopic approach. Okay. Before coming into it, we should know what are the thermodynamic properties by macroscopic approach. So property is basically the specific characteristics which identify the entity. Okay. And what is thermodynamic properties? The properties which relate to the thermodynamics. So basically the specific characteristics which identify the thermodynamic system. Okay. Now I'm coming into the philosophy of this thermodynamic property, or a property rather. So if you consider that Mr. X having two specific characteristics, one is he has 80 kg weight and he is 2 meters tall. Okay, so these are the characteristics of Mr. X. Okay, where when there will be a police investigation, these are the characteristics that will be put to use. Okay, so basically, so these two characteristics basically identify Mr. X. So how it is obtained is not the concern of us. That is 80 kg weight, how he obtained or how he became 2 meters tall, that is not our concern. Is that for identification we need these properties. Okay. So these thermodynamic properties can be of two types. One is an extensive property, another is an intensive properties. What is extensive property? The extensive property depends on mass. That means more the mass, more will be the extensive property. That means this extensive property depends on the extent of the system. Okay. Another very important thing is that the intensive property. And the intensive property does not depend upon the extent of system or the mass. Okay. An example of extensive property, if you say, that will be internal energy, volume, enthalpy. Okay. And for intensive property, it will be the pressure at a point, temperature at a point. Okay. Or I can give you an example of the more elaborate concept of extensive property. If you consider a system like this, where it is divided into several regions, and the property phi in each region is phi 1, phi 2, phi 3, and like that. Okay. If the overall property of this whole system will be the summation of all individual properties, then it will be the extensive property of that system. Okay. Same thing for the intensive property. The system is divided into regions, several regions, and the property phi in each region is phi 1, phi 2, and gradually it is like this. So if the property phi in every region is equal, that is phi 1, phi 2, and phi 3 like this. So basically this will be the intensive property of that system. Okay. Okay. And a very important thing, the example of which I told earlier, that the example of extensive property may be volume, mass, internal energy. Okay, like this, and it is denoted by big letters generally. Okay. And for an intensive property, it will be P, T, it is pressure at a point, temperature at a point. Okay, basically depending on particular positions. Okay, and what we can say is that it's denoted by small p for pressure and big T for temperature, and it's an exception for that because we generally denote extensive properties by capital alphabet. Okay, now what we're gonna discuss is basically the specific properties. Okay, the specific property is basically the extensive property per unit mass of the system. Okay, example is that specific volume and density. Okay, it's basically the special case of an intensive properties because we are considering it on a mass basis or volume basis, whatever may be. Okay, so basically if you consider of an specific characteristics, basically the specific properties, So that will be an special case of intensity properties. Okay. Another thing that is denoted by the lowercase letters. Okay. That is, for volume it will be small v, for density it will be rho. Okay. Another thing which is very important is the thermodynamic state. Okay. That means we initially told that the specific characteristics basically identify the system. Okay. So what do you mean by the state of the system? The state is basically the function of properties. That means these properties will denote the state of a system. That means it gives complete description of the system. Okay. But the system, there are many properties are there. Okay. If you consider there are n properties of in a system, but do all the properties, do we need to completely define the system? No, we do not need the all properties. We only need the properties which will remain uniform throughout the system, and that will specify the finite system properties. That is, they should not change with time to specify the state of a system. That means, so definitely what will define means the property that will remain invariant with respect to time. Okay. So suppose we considering a system which consisting of n number of properties, and do we need all the properties to define the state of a system? No, we will not need the all properties. We only need those properties that are the independent intensity properties which will define the state of a system. That is, they will remain invariant with respect to time. Okay, and that will be denoted by a Gibbs phase rule. Okay, and that is F equal to C minus phi plus 2. Okay, this F is basically the number of independent intensity properties C is number of components and phi is number of phase. Okay, and 2 is basically the two thermodynamic variables. One is pressure and one is temperature. Okay, so this F is number of properties, independent intensity properties required to fix the state of a system. Okay, so what do you mean by this formula is known as Gibbs phase rule, and this F will be the number of independent intensity properties needed to define the state of a system. Okay, we all know what are the components means, and what is a phase. The phase is basically, if you say, is basically the quantity of mass that is homogeneous throughout in the chemical composition and in physical structure. Okay, example of it may be solid, liquid, and vapor. Okay, but if a phase consisting of more than one phase, it is known as heterogeneous system. But basically, what we're gonna deal is that is of homogeneous system. Okay, so this phase is basically we found out that the chemical composition and physical structure is homogeneous throughout. Okay, and from that Gibbs phase rule, we can able to find the number of independent intensity properties need to define the system. Okay, now a special case that if this phase number of phases exist is 3, that means maybe solid, liquid, and gases, the 3 phases coexist in equilibrium, and the number of component we use is 1 if you consider for in water, it is H2O. So we will have this F is 0. That means number of independent intensity properties at this point will be 0. So it's special case which is known as triple point of water, that we do not need any independent intensity properties to define the state. Okay, that the temperature and pressure is fixed. If you see the P versus T curve, Okay. So this triple point do not need any independent intrinsic property for the definition, for defining the system. Okay. So this Gibbs phase rule will definitely show the number of independent intrinsic properties needed to define the state of a system. So this state is basically the function of properties.